Hi, I'm Teacher Michael again, and welcome to Science 9, 4th quarter, week 6, Heat, Work, and Energy. Heat, Work, and Energy. The production of heat is one of the driving forces of human activity. So we need heat for lots of human activities, or we need heat in our daily lives. We use it in daily chores like cooking and drying and ironing of clothes. It is also needed to greater extent in commercial and industrial applications, especially in the field of manufacturing where many substances are made with the use of enormous amounts of heat. So heat is very essential in manufacturing of the different products that we use. So, understanding how heat works and how it interacts with various objects is studied since it will help in making many different processes efficient. So, napaka-importanteng pag-aralan ng heat dahil lahat ng ating ginagawa, lahat ng produktong ating ginagamit ay kinailangan ng init. At para maging efficient ang paggamit natin ito, dapat natin itong pag-aralan. Heat and temperature are often confused with one another. Heat is different from temperature. So, how is heat differ from temperature? Temperature, in the simplest sense, is a measure of hotness or coldness of an object. An object that is hot has high temperature, and a cold object has a lower temperature. So, ang temperature, ito yung pagkainit or init at pagkalamig ng isang bagay. So, kapag malamig ang isang bagay, malamang meron siyang mababang temperature. Kapag mainit ang isang bagay, ito ay may mataas sa temperature. So, to get the temperature of an object, we are using thermometer. So again, temperature is the hotness, or it is a measure of hotness or coldness of an object. Init o lamig ng isang bagay. Now, on the other hand, heat is energy transferred from one object to another due to its difference of temperature between the two objects. So, ano naman ang heat? Ang heat ay nangyayari dalawang object ay magkaiba ng temperature. Once they in contact, the energy is being transferred from warmer object to the colder object because of their temperature differences. Heat flows. So nagkakaroon ng init. At nagkakaroon ng init because also the energy is being transferred from this object, from warmer object to the colder object. So sa madaling sabi, nagkakaroon ng init kung ang dalawang object ay magkaiba ng temperatura. At ito rin ang nagkakaroon din ng init dahil sa pag-transfer ng energy from the warmer object to the colder object. Temperature, it is how hot or cold an object is, while heat is transferred to the object. You have learned that energy is needed to perform work. We cannot do work without energy. When work is done on a body, energy is transferred on that body. So kapag nag-apply tayo ng work sa isang bagay, yung energy ay matatransfer mula sa atin doon sa bagay na in-applyan natin ng work. The transfer of energy to the body increases the internal energy. So, yung energy na transfer natin doon sa body na in-applyan natin ng work ay matatransfer. So, what will happen on their internal energy? The internal energy of that object will increase. Example, the stirring of coffee. So, nagtimpla ka ng kape. So, para mas ma-dissolve yung kape, doon sa tubig, kailangan mo siyang haluin ng maigi. So, sa paghalo, you are applying energy because you are doing work. You are doing work by stirring the water which has a coffee. So to make the coffee dissolve more, you have to stir the water. So since you are applying work on the water is receiving energy. You are transferring energy on the water. So therefore, the internal energy of the water increases. Okay, so what will happen now? The internal energy will later decrease as the body converts it to heat. So once the internal energy is increased in water because you applied work, you transferred energy. Therefore, later on, the internal energy of that water decreases, and it will convert into heat. Now, the heat will help to dissolve more the coffee on that water. Heat is the energy transferred from one body to another as a result of temperature difference. As I mentioned, kapag ang dalawang object na magkatabi ay magkaiba ng temperature, there is what we call flow of heat. Meron tayong tinatawag na heat. Energy can be converted or transferred to a body as heat, and the body can perform work. So aside from the fact that the two objects has different temperature that results of heat, heat is also a result of transferred energy. So the energy that is being transferred to a certain object can be converted to heat, and that heat can use to perform work. Okay, so for example, in this picture or in this simple GIF, it shows that the water is being heated. So once it boils, the boiling of water will push the piston up and ward. Because of downward and upward movement of the piston, then this machine works. So meaning to say, because of the heat being transferred on the water, there is a performance of work. James Prescott Joule investigated a mechanical equivalent of heat. He set up an apparatus in its simplified form. The weight were made to fall through a certain distance. So this is the weight. It was fall in certain distance. As they dropped, the wires to which they were attached made one shaft and paddles turn. So because of the dropping of the weights, eventually the paddles turn. The friction resulting from the paddling warmed the water. So because of the friction from the paddling, hits the water and raise its temperature. So once the water is being heated because of the continuous paddling, then the water temperature increases. Almost all the work done on the machine was transformed into heat. Using this device, he found out that 4.194 joule is equivalent to 1 calorie. A calorie is a unit of energy that is equivalent to amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius, ideally measured from 14.5 degrees Celsius to 15.5 degrees Celsius. How is energy conserved when you eat breakfast? Is the energy being conserved when you eat breakfast? The chemical energy in food will be converted into mechanical energy that enables you to do work. So for you to be able to have energy and to do work, you have to eat. So the chemical energy from the food that you eat will be converted into mechanical energy that enables you to do work. But not all the chemical energy is converted to mechanical energy. Some will converted in the form of heat. So hindi lahat ng chemical energy mako-convert to mechanical energy for you to do work. Some of the mechanical energy from the food that you eat is converted to heat. So in short, or in a sense, we need heat in order to maintain our heat in our body. In order to maintain the heat in our body. For that reason, some of the chemical energy from the food that we eat is being converted into heat. So the chemical energy that you gain from the food that you eat is being conserved. Walang nasayang. Kasi yung iba doon, naging chemical energy, yung iba doon, naging heat. The concept of conservation of energy states that energy cannot be created nor destroyed. Ang energy ay hindi pwedeng magawa or hindi pwedeng magkaroon ulit ng panibagong energy at hindi rin pwede itong mawala. Kasi conserved siya dapat. The first law of thermodynamics is actually based on this concept. The first law of thermodynamics states that the change in internal energy of a system equals to the difference between the heat taken in by a system and the work done by the system. The law is expressed as delta U is equal to Q minus W, where Q is the amount of heat flowing into the system, W is the net work, what is the work done by the system, and delta U is equal to the change in the system's internal energy. This is derived from the conservation of energy given as how heat is related to work. Q is equal to W plus delta U. What is internal energy? Internal energy of a substance is the sum of the molecular kinetic energy, that's due to the random motion of the molecules, the molecular potential energy, that's due to the forces that acts between the atoms of a molecule and between the molecules, and other kinds of molecular energy. So internal energy is the sum of all the potential and kinetic energy of a certain body or certain system. When heat flows in instances where the work done is negligible, the internal energy of the hot substances decreases, and the internal energy of the cold substances increases. So meaning to say, in a heat flows, once the heat flows or there's a heat, so nagkakaroon naman ng heat kapag ang dalawang bagay ay magkaiba ng temperature, kung ang isang bagay ay mainit at ang isang bagay ay malamig. So the internal energy of the hot substances decreases once they're in contact. The internal energy of the hot substance decreases, and the internal energy of the cold substance increases because the energy is being transferred from the hot object or the hotter object to the colder object. Because of the energy transferred or because of the energy transfer, there's what we call heat. While heat may originate in the internal energy supply of a substance, so it is not correct to say that a substance contains heat. The substance has internal energy, not heat. The word heat is used only when referring to the energy actually in transit from hot to cold. So again, heat or there's a heat because of the temperature difference of the two objects or the two systems, and there's a heat because of the transfer of energy from one object to another object. We will use Joule as our SI unit for energy. The first law tells tells us that a system's internal energy can be changed by transferring energy by either work, heat, or combination of the two. Normally, heat flows from a hotter object to a cooler object when the two objects are placed in contact. So again, that's the natural process. Ang init ay nagfo-flow mula sa mainit na bagay papunta sa malamig na bagay. It is for this reason that a pot of coffee feels hot to touch, while the scoop of an ice cream feels cold. The temperature of an ice cream is lower than 37 degrees Celsius. When you touch a cup of hot coffee, heat flows from a hotter cup to a cooler hand. So from the hotter cup, which is sabi nga natin, heat flows from hotter object to colder object since mas mainit ang kape kaysa sa iyong kamay. So ang init ay dadaloy mula sa kape papunta sa iyong kamay. When you touch a cone of ice cream, heat again flows from hot to cold. In this case, from the warmer hand to the colder cone. So since the ice cream is much colder than your hand, therefore your hand is much hotter. So the heat flows from your hand to the scoop of ice cream. The response of the nerves in the hand to the arrival or the departure of the heat prompts the brain to identify the cup of coffee as being hot and the cone of ice cream as being cold. So it's just our brain that identifies that we are holding a hot coffee and a cold ice cream. Now, if the natural process wherein heat flows from hotter object or high temperature object to lower temperature object, can we do the reverse process? Pwede ba nating baliktarin yung proseso wherein heat flows from colder to warmer object? We can, with the use of heat pump. Heat pump is used to reverse the process. It is a device that allows heat to transfer from a colder reservoir to a warmer reservoir, which is not a natural process. So, pwede using heat pump. We can reverse the process which is allowing heat to transfer from cold to warmer object. Work is required for the heat to flow from lower to higher temperature. So, because of the work being done by the heat pump, the natural process is being reversed. So, this work is provided by the motor of the heat pump. So, this is the motor of a heat pump. So, to make it simple, yung refrigerator, the aircon, it has heat pump, which reverses the process of the heat flows from colder to warmer object. In doing so, work should be done. So to reverse the natural process, wherein the natural process, the heat flows from warmer object or high temperature object to lower temperature object. To reverse that, we have to apply work. Mechanical energy is required for this to happen. Second law of thermodynamics is applied in this activity or in this process. Second law of thermodynamics states that heat will never of itself flow from a cold temperature to hot temperature object. The work is provided by the motor of a heat pump. So, the second law of thermodynamics states that ang heat ay never mag-flow on its own way from colder to higher temperature object. Mangyayari lang yun kung meron tayong in-apply na work. na pwedeng i-provide ng motor ng isang heat pump. So what is a spontaneous and non-spontaneous process? In a spontaneous process, heat flows from higher temperature to a lower temperature. It does not require any external energy to occur. So this spontaneous process is a natural process wherein the heat flows from higher temperature to a lower temperature. So ito yung mga natural na proseso. Aside from heat, we can compare the other processes in the spontaneous process, like lahat ng bagay ay nabubulok, lahat ng bagay ay kumukupas. So, as the time goes by, no, lahat ng bagay ay, lahat ng tao ay tumatanda. That's a natural process, and that is an example of we can say that those process is also an example of a spontaneous process because they are natural. While in non-spontaneous process, heat flows from lower temperature to higher temperature. It needs mechanical energy to occur. So, for heat to flow from lower, mas mababang malamig na bagay, papunta sa mas mainit na bagay, kailangan ng mechanical energy or kailangan ng external energy para magawa ito. So, non-spontaneous process is not a natural process. So, nangyayari lang tong proseso na to because of the application of mechanical energy or application of external energy for that process to occur. For activity 1, you have to identify if the following situation is an example of a spontaneous or non-spontaneous process. Activity 1, distinguish the process as spontaneous or non-spontaneous process. Number 1, melting of ice. Is it spontaneous or non-spontaneous? Again, pag spontaneous, natural process. Non-spontaneous, it is a not natural process because we reverse the process of the spontaneous process because of the application of external energy or mechanical energy. So, going back, is melting of ice is a spontaneous or non-spontaneous process? Natural bang natutunaw ang yelo? Malamang. Rusting of iron, is it spontaneous or non-spontaneous? Marble going down the spiral. So, lahat naman ng bagay ay bumababa dahil sa gravity. So, natural yun. So, marble going down the spiral, is it spontaneous or non-spontaneous process? Going uphill. Kaya mo bang umakyat sa hill nang wala kang energy na ina-effort or ina-exert? So, is it spontaneous or non-spontaneous? Keeping the food fresh from the spoilage. Food eventually will spoil. Mabubulok at mabubulok ang mga pagkain. But we can keep it from spoilage by putting the food in a refrigerator. So, you applied mechanical energy from the use of refrigerator. So, keeping the food fresh from spoilage, is it spontaneous or non-spontaneous? Guide questions. Number 1, which of the following is spontaneous processes? So, from the 5 items, which are the following is spontaneous processes? Number 2, which of the given example is non-spontaneous process? Number 3, what is the difference between spontaneous and non-spontaneous process? And number 4, what is needed to reverse the process? For your activity number 2, you have to create or to do an experiment that will showcase the heat and work model. For activity number 2, objective, make a simple model that shows heat can do work. Materials: candle, match, cardboard, scissors, pointed stick, bond, paper, glue. Precautionary measures: be careful when using fire and scissors. Ask for adult supervision if necessary. Procedure: Number 1. Cut a piece of cardboard to a circular shape. Number 2. Cut a circular piece of bond paper and cut a spiral out of it as shown in figure 2. Number 3. Glue the stick to the cardboard so that it stands upright on the cardboard. Number 4. With the stick pointing upwards, make a crease on the top of the spiral cutout and let the crease rest on the pointed end of the stick. Let the spiral fall. Refer to figure number 3. Number 5. Put the candle below the spiral, resting in the cardboard. Light the candle using the match. Make sure that the candle light does not reach the bond paper. So for you to have an idea about this experiment, let us take a look on this next slide. So this is how this experiment looks like. The candle is lighted. What is happening on the spiral paper? Guide questions. Number 1. What happens to the spiral paper when you light the candle? Number 2. What causes the spiral to behave that way? Short quiz. Choose the letter of the best answer. Write the chosen letter on a separate sheet of paper. Number 1. First law of thermodynamics deals with letter A, conservation of mass, letter B, conservation of energy, letter C, conservation of momentum, letter D, conservation of pressure. Number 2. All of the following are examples of spontaneous reactions or process except A. Going uphill, B. Melting of ice, C. Keeping the food fresh from spoilage, and letter D. Rusting of iron. Number 3. How does the water from the deep well move upward? So, letter A. It occurs naturally. Letter B. It uses water heat pump. Letter C. It is a spontaneous process. Letter D. It flows from higher temperature to cooler temperature. Number 4. All of the following are example of non-spontaneous process except letter A. Keeping the food fresh from spoilage. Letter B. Going uphill. Letter C. Melting of ice. Letter D. Breakage of egg. And number 5. What is the use of heat pump? Letter A. It is used to transfer heat from a colder reservoir to a warmer reservoir. Letter B. It is used to transfer heat from warmer reservoir to a colder reservoir. Letter C. It is used to transfer heat to a colder reservoir. And letter D. It is used to change heat. Okay, reminder, answer activity 1, 2, and short quiz of this week 6. Total points is 25 points. Good luck. Thank you for watching and listening. Have a nice day.